Hi there, welcome back. Welcome to the second video in the Grundig Type 90U restoration. This little guy in the last video, as you saw, was a little bit ill. It was giving absolutely nothing. We heard a little bit of hum, but nothing much else. And as promised, I went through the power supply and the amp section, and I've got a few things to show you. But before I show you what was actually done, I want to show you something which I think is quite interesting. Let me switch it on. I have it on the dim bulb tester. I've got two light bulbs. So I have a 100 watt lamp in series with this. The restriction is on and everything else, and it's totally isolated. The transformer is an isolation transformer, so we have absolutely no connection to mains earth at the moment. Now, if I put it on, as you can see, the dial lamp goes on and everything is hunky-dory. Okay? Now, I have the voltmeter on AC volts connected. The negative pin is connected to mains earth at the back there by the plugs, and the positive, or the other terminal, is connected to this contraption, which is earthed to the chassis. And observe, I'm going to bypass the isolation transformer. Here goes. That there is 200 volts. It's 200 volts, and it's exactly the same voltage that I'm seeing on the dim bulb tester. In other words, the transformer, or rather the light bulbs, are still in series, so they're dropping the voltage a little bit. But that thing there, everything that's metal over here, has got 200 volts on it. And believe me, this is not phantom voltage. This is not that sort of voltage which the minute you touch it, it disappears. This is the type of voltage that the minute you touch it, you can disappear. This thing is a hot chassis at the moment, okay? It is an absolute hot chassis at the moment. Now, I'm going to show you that by removing the plug, we get a difference. Okay, 200 volts, 199, 200 volts, okay, 150 milliamps. I'm going to reverse that plug. Watch the meter. Two volts, 200 volts, okay? What does that mean? Well, initially, when you first look at this, it wouldn't make any sense, because this thing is not a typical hot chassis set. Usually hot chassis don't have a power transformer, right? And somebody asked me this question specifically very recently in the comment section. How do I know it's hot chassis? And I said, generally, when you have a transformer, it is not a hot chassis, but not exclusively. There are exceptions. This is one of the exceptions. Let me show you. Now I know that the chassis is at 2-point-something volts, right? So I can touch it, no problem. And you can clearly see this thing has got a transformer. This is the power transformer. That is the output transformer, okay? And I can touch it. I can touch the chassis now. It is still, I've still bypassed the isolation transformer, but I can touch it because at the moment, this thing is connected to neutral. And if you're not aware, I'll tell you again, in Portugal, we don't have polarized plugs. In other words, our mains plugs can go in either way. This is a typical one. It's still in the plastic. It can go in either way. There's absolutely no restriction as to how it goes in. These plugs actually come with a hole around here, which it should be possible to make it polarized if you have this pointer sticking out of the sockets. There is no such thing in Portugal. These plugs will go in just as easily one way as they will the other way. Which means if you've got a radio where the main supply, one of the legs of the main supply is going to the chassis, in other words, it's becoming ground, you are at a 50% risk of getting electrocuted if you touch anything metal on that radio. That's exactly what's happened here. And we have the transformer, right? You can see that. Let me show you why. This was a little bit baffling for me at first. I didn't realize what we were looking at, but it's pretty obvious once you figure it out. This is what we're facing. This is our schematic so far. As you can see, I've got quite a bit of this painted in. In fact, there's quite a bit more than that. You can see this entire section over here has been painted in. In other words, it's been checked. The red indicates components that have been replaced, but we'll look at that in more detail in a second. Let's look at the power supply. This is the transformer over here. We have the rectifier tube, the EZ80. But the interesting bit is on this side. And let me explain. If you look more carefully, what we actually see here, coming in here is a switch. That switch has been checked, it's working. It goes through here. There's a bit of an inductor there, a bit of a coil. This is basically to reduce noise going back into the mains line. Then there's a fuse, and the fuse can be on the 220 volts or the 110 volts input. So far, it looks like a normal situation. Now, here's where it gets a bit funny. The other line from the mains comes in, goes through a coil, a winding of sorts, and then it goes through another switch to ground. And this took a little bit of figuring out, but when I saw this coil and where it went to, it made sense. This thing is being switched through directly to ground. Now, the hot chassis situation, if you're not aware of it, it means that if this line here happens to be neutral in your plug, it means your plug is connected to the chassis. You can touch the chassis, you don't die. If, and live would obviously come through here. If, on the other hand, you happen to get the plug the wrong way around, and that is live, mains live, then your mains live comes in through that coil and it goes to ground. The system itself doesn't care. 220 volts AC is 220 volts AC. As far as this thing's concerned, it doesn't matter which way around you put it. As far as you're concerned and your contact and your interaction with the chassis, you will worry about the difference, believe me. So, what is the situation here? Well, what we've got here is the mains comes in, goes through there, goes through the fuse. This is 220 volts, it's actually 230 something. But then what we see here is on the transformer, it shows it going straight through. It goes into the transformer winding, and it goes straight through to the selenium rectifier, to the two diodes. I said it again, it's not a selenium rectifier. I made this mistake, I think, twice in the other video. To the rectifier tube. My bad. It goes to the two diodes of the rectifier tube, which then comes out as rectified voltage. In other words, 220 is rectified to give you your B+, which is a DC voltage relative to ground. Okay? Now this 220 coming in is exactly the same, because at that winding it goes straight through, which means your AC mains is going straight through. Why all the rest? Well, if your mains was 110 volts and you connect the fuse instead of there, you connect the fuse over there, then 110 volts would come in here, and this thing over here is an auto transformer. Now, an auto transformer is effectively a transformer that has one winding with various taps on the same winding. It does not have a separate winding for a secondary. Okay? So if 110 goes in here at a certain part of the winding, and there are more coils, more windings going on, it steps up the voltage to 220 volts. In other words, your system needs 220 volts AC to come in. And it doesn't really care how it gets it. In this case, it either gets it straight from the mains, or if the mains happens to be 110 volts, it steps up to 220 volts. Okay? So this winding, this tap on this winding, is at halfway between 0 turns and maximum turns on the auto transformer, which is why 110 becomes 220. That's how an autotransformer works. That thing there is 0 because the AC goes to 0 over there. So effectively you're connecting your AC mains between here and either here or here. The other tap on this autotransformer is your 6.3 volts for your heaters. Okay. Now it's also referenced to ground. It is also linked to the mains wiring, the mains connection. In other words, to the primary of this autotransformer. So this whole thing is dangerous. Any way you touch on this thing, whether you touch your chassis, ground, or whether you touch the lamp, you know, the other connection of the lamp, if you have this the wrong way around, if you have live over here, then your lamp is effectively going to let live through because there's such a small resistance on there. Your lamp is, if you touch that end, you'll get zapped as well. So 6.3 volts comes out of here and it feeds the two branches of tubes. The ECH81 over here with some filtering because it requires it to be pretty clean and noise free. This is right at the mixer oscillator of the radio. The ECC85, same thing. It's the tube that's used in the FM front end. That's why this particular branch of the 6.3 volts is filtered, capacitors, inductors and so on, to keep it noise free. And also you have a branch going on here to the other tubes and to the lamp, and these now are dealing with less sensitive parts of the circuit, so they can take the unfiltered or less clean portion of the 6.3 volts. Okay, there's one other thing to look at here, and that is this coil over here. This is actually a winding around another winding. This is effectively a transformer, and this XX is the antenna for FM. If we go and look at the FM front end, what we have here is the AM antenna coming in, okay, and we also have XX. Now this XX is the external socket that comes from that winding down there. There's a cable and plug, rather not socket, plug, which plugs into the back to the FM section, the antenna input at the back of the set. That's your XX. Now you'll also notice that one of the precautions they've taken, because this could be a hot chassis, is they've actually not made the antenna earth directly connected to the ground. There's actually a capacitor between the two. And the idea is, if you've got this thing the wrong way around, if this is live, mains live, and you've got a capacitor, you'll get less of a zap. You still get a tingle, but you get less of a zap because it's isolated with a capacitor. The reason I say you get a tingle is because you are earth, you're effectively mains earth, and if you touch it, you got 50 hertz over here. In Portugal we work with 50, not 60. So 50 hertz, some of it will go through that capacitor. Obviously not the full power of 230 volts, but you'll get a tingle. But it does have the isolation so you don't cock up. But that explains quite a bit of that supply, and it also explains why you have to be careful, even if you see a transformer. So, what is a hot chassis? Well, either the 220 goes straight into the rectifier section, or you have an auto transformer, and in this case, the purpose of the auto transformer is twofold. One, it's to allow the set to work on 110 volts, and the auto transformer steps it up to the 220 that it needs, and also to provide the 6.3 volts for your heaters. And in this case, this is again very deceptive, because in hot chassis sets, the tubes are clearly identified as being different from the ones they use on a transformer set. These tubes all work on 6.3 volt heaters. The ECH81, the ECC85, the EF89, EABC80, EL84, even the EZ80. They all work on 6.3 volt heaters. Now, with the hot chassis set, this would be a UCH81, not an ECH81. And the way that would work is the heaters are in series to total 220 volts. There's usually a resistor to drop some voltage, but that's a different story. So be very, very, very careful. I have to treat this set as a hot chassis, which is effectively what it is. That's explained ad nauseum. Carrying on. The 220 volts, whether it comes in straight from the mains or from the 110 stepped up, comes in here, goes, as I said, through this is basically current limiting resistors, into the diodes of the two separate diodes of the rectifier tube, not selenium rectifier, and then it comes out of there as B+, and it goes to the first filter cap over here. That one. That is half of a can containing the two filter caps. 2 by 350, 385 volts, 50 microfarads each. Now, the can that I found in there was totally kaput, and I replaced it with two 47 microfarads, 350 volt capacitors. So that was replaced. Then the voltage comes up here. Forgot to draw that line in. It comes in to the output transformer. Remember, this will be, what does it say? It doesn't actually say what voltage it is, does it? This voltage should be, well, let's see what's at the top here. EL84, that should be about 212, 213, say 215 volts. These readings over here for the anode of the EL84 depends on whether it's FM, AM or pickup. Let's call it 220 volts, okay? DC now, this is DC. So this comes up here into the output transformer. Through the output transformer, it uses it as a load, and to the anode of the EL84, which is driving the power through that output transformer. Now, this resistor here, this 1K resistor, is the one at the top that I showed you that was burnt out. That's been replaced. This capacitor is basically to reduce high frequency noise, or rather to reduce the high frequencies, and also cuts out the frequencies you don't want to go through, and obviously makes it less prone to oscillation. The EL84 is cathode biased with 140 ohms and 25 microfarad cathode bypass capacitor. This is basically just the biasing of the EL84. That capacitor just allows more frequencies, low frequencies, to go through. It's got a grid resistor, a grid stop resistor of 1K. That was checked, that's fine. 1 meg to ground, that was fine. That capacitor there was one of the ones, the crazy ones they'd replaced. I replaced it again because it was a total mess up. And then the other lines have been checked. As you can see, there's one thing I forgot to mention. This B+ goes in here. It comes out through, it goes through part of a winding, part of the winding of the primary of the output transformer. And this section of winding effectively acts as a sort of an inductor. It is an inductor, obviously, but it's a sort of a choke, which helps to reduce ripple. And over here, you've got the second B+, which is slightly lower. And it goes to the second filter cap that was also replaced, and that's the B+ for the rest of the tubes and the rest of the circuit. So that section was tested and checked. This was all done with access to the pins of the tubes that are removed, and in some cases directly onto the into the components underneath the radio. My purpose obviously was to get this section to work. Okay, I wanted audio to come through. I wanted to make sure that the audio circuit was working. And for me, the audio circuit working means that you put a signal onto the pickup, the TA input, and you should hopefully get audio going through the preamp part of this tube and through the power amp and then your transformer and speakers. In the last test, we saw we had nothing. So I did some checking and I did some replacement. These components were replaced. I haven't completed the audio circuit, but I wanted to test it and I wanted to try something, and I think I found the problem. I will show you just very quickly. Your pickup signal comes in here. This would be a selection between pickup and radio. So pickup circuit comes in here, goes through that capacitor there. It goes to the top of the volume control. You basically use the volume control as a potential divider to remove part of the audio. and that gets fed into there, into the grid of the yes, it's the grid of the EABC80's triode. This EABC has got 1, 2, 3 diodes and a triode. The triode simply acts as a preamplifier. The signal's fed out of here, goes up there, and with the effect of this resistor and that resistor, mostly this one, it acts as a load, and your signal comes out here, goes into the grid and gets amplified, and you hear the audio. This section here, when the audio comes out of here, it's effectively full range, as it were. Here you've got a variable resistor. It's the tone control, and in fact the tone control does exist and it's now working. And what this tone control does, it's the simplest you can get. There's a capacitor, a 10 nanofarad capacitor to ground. Now if you put a 10 nanofarad capacitor straight onto an audio signal coming out of there, it'll leak off a heck of a lot of the higher frequencies to ground, which means they won't go through to your power amplifier. What you're doing with this variable resistor is you're either increasing or decreasing the amount of effect that this capacitor has. In other words, you are tuning which part of the frequencies you want to leak off to ground, that you don't want to go through. So the smaller this resistor, the smaller you make this resistor when you turn it counterclockwise, right? The higher, or rather the more treble sounds will leak to ground and get lost forever and ever. And that means that your tone becomes very bassy. If you make this high, in other words, you turn it completely clockwise, very little, this thing has very little effect, because very little of that audio, very few frequencies on that audio get leaked to ground, and most of your audio frequencies go through and you get a more trebly sound. Okay, that's very simple, very normal procedure in these radios. It's the simplest tone control you'll find on these sets. Now let me show you the radio, what I've done, and we'll do a test and I'll show you what it was and what was stopping it from giving us any audio. Right, let's do that. Now this is rather cramped in here, so it might be a little difficult to see some of what I'm pointing out, but here I've replaced the 2 filter caps with, or rather the 1 filter can, which has 2 caps inside, with 2 separate 47 microfarad capacitors. That's been replaced. This is the EL84. I've replaced the cathode bypass capacitor over here. You can barely see that. I've replaced the grid, or rather the capacitor that brings the signal from the preamp section to the power stage, which is one of the important ones. That one had been replaced, but it was very badly done. I replaced that. This one is still in place, something else. There was another one replaced here, which I can't see. Down here, is it? Where is it? Oh, down at the back there. You can barely see it over there, the back. That is the one that goes from the tone control. The actual tone control is that part of the potentiometer over there. That was sprayed with contact cleaner, moved around a lot, and it's now actually moving and working. So that's done. The volume pot was cleaned with contact cleaner, so that's okay. By removing that can from here, I gained quite a bit of space, so it made it a bit easier to work on there. Other than those few components and the checking that's been marked off in green on the schematic, nothing else here has been changed. Nothing else here has been changed. So I did all these changes, tried it again, and got absolutely nothing. And then I remembered something. I remembered that when I looked at the tubes, the EL84 looked a bit funny, and if you recall, I rubbed it and thought that white stuff was only on the outside, and I thought maybe the white stuff is on both ends, and I checked it again, and I believed then the EL84 was gone. So what I did is I replaced the EL84 on there. That's the only tube I've replaced. All the other tubes are original, and I've got it connected to At the moment it's to the FM antenna, and let me show you what we get. We have reception. We also have quite a strong buzz, hum, but I'll get to that in a minute. Let me put this mini whip on the AM side, connect mini whip, still the hum. So we have medium wave, long wave, whatever that is, that's long wave somewhere. And this is BBC4 from the UK.
Travel and tourism firms have been urging the government to rip up its quarantine measures. They're being introduced too late and
that's on 198 kilohertz long wave. And of course our beacon from the Porto Santo airport, I believe. So everything seems to be working. We've got stuff working. We've got reception. It's not particularly good, this reception, but it's there. And the other thing I've realized is this buzz that we're getting is actually due to the fact that I'm using an isolation transformer. And I will show you. Let me put it on FM again. Now, I corrected the orientation of the plugs, so this thing, if I remove it from isolation transformer, this thing should be neutral, but I'm not going to touch it anyway. I'm just going to flip off the isolation on the transformer and see what happens. That's without an isolation transformer. No buzz. With isolation transformer, there's a buzz. In other words, the isolation transformer is creating the hum that we're hearing here, and the minute you actually connect it to live and neutral, and really it doesn't matter which way around, the noise doesn't care which way around it is, but it then becomes connected to earth on one point and the buzz disappears. So this thing is working fairly well. Reception isn't particularly grand, and the dirt and everything else is still here. But as far as function is concerned, I think everything's there. And if I touch the back on the... I'm a bit nervous about touching the back on this thing, by the way, as you might have noticed. But if I touch the back on the pickup input and I put pickup on here, I will hear the buzz, the hum, which is what happens when you touch the pickup input. So we've got the basis for a fairly interesting restoration. I'm now going to do the usual, which is complete the changes of components and checking of the circuit. I might just come back with all the capacitors changed and the entire circuit checked, because afterwards I have to do a heck of a lot of cleaning on here, because this is really filthy. As I mentioned, it actually smells of nicotine. So I've got quite a bit of cleaning to do here. And yeah, and this one's going to be, again, a keeper. I'm going to have to do something about a warning system for the plug. And I've done it before where I put a little red lamp on here, and if you happen to plug it the wrong way around, the lamp goes on and it warns you. I'm going to do it slightly different this time. I'm going to try and put that lamp inside the mains plug. So when you actually plug it in, if a red LED comes on, you know you've got to flip it the other way around. Maybe even put a green one if you flip it the right way around, okay? So this was just makes it a bit less intrusive on the radio, and I wanted to do the same thing. We don't have any way of knowing which way our plugs are connected in Portugal, unless you touch it. That's not the idea. And so if I put that little indicator on the plug itself, you will know, we will know. And that's probably what I'm going to do. So that's it for today. I've got a bit of work to do this weekend on this. Thanks for watching. Hope you've enjoyed that. And if you have, please click like and share and subscribe and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Thanks for watching. Bye for now and stay safe.